Welcome to Educator.com. Today we're going to be discussing monomials. First we'll define them and then talk about how to work with them. Beginning with the definition, a monomial is the product of a number and 0 or more variables. So it's the product of a number such as, say, 6, and it may be multiplied by no variables, so then you would just have 6 or 5, a constant. Or you may have a number multiplied by a variable such as 2x or 3y squared or 3xyz. So all of these are monomials. It may just be a variable such as y alone, which actually is multiplied by a constant. It's just that it's 1 and we don't usually write out the 1. So all of these are monomials. A power is the product of a number or a variable multiplied by itself n times, where n is a positive integer. So to make this more concrete, first what this is saying is that if you have a variable or a number and it's x to the n power, that's telling me that I'm multiplying x by itself n times, where n is some variable, some number, some integer. An example would be x to the third. So if n equals 3, then x to the third is x times x times x. And it would be the same way if you were using a constant. 5 to the fourth is 5 times 5 times 5 times 5. And there's some terminology involved with this. The number here, this would be the base. And the power that you're taking it to is called the exponent. So x to the third, this is the base, x is the base, and 3 is the exponent. And that's terminology that we're going to be using throughout this lesson. There are 3 important properties of exponents that we're going to discuss that allow you to work with and multiply monomials. The first one says that if you have 2 exponential expressions with the same base, you multiply them by adding the exponents. So I have 2 exponential expressions here, a to the m and a to the n. They both have the base of a. So if I want to multiply an exponential expressions with the same base, add the exponents. That's what this is saying. An example would be if I had x to the third times x to the fourth. I'm going to keep my base of x and I'm going to add 3 plus 4 to give me x to the 7th power. Okay, so that is this property right here. The second property talks about if I have an exponential expression raised to a power. So it's a power raised to a power. In that case, I multiply the exponents. So for this second rule, I am going to, if I have a power raised to a power, multiply the exponents. An example for this situation would be if I had x squared raised to the third power. In that case, I'm going to multiply 2 times 3 to give me x to the 6th. In my third example, I have a product raised to a power. So this is discussing if I have a product raised to a power, then I can break it out so that each part of the product is individually raised to that power, and that allows me to get rid of the parentheses. So an example of this would be if I had x, y to the third. So if I had x, y raised to the third, that's the same as x cubed, y cubed. And for all of these, it's possible to work them out slightly differently to explain why this is true. For example, with this third one, if I had just written out xy to the third as follows, I could show that this is equal to xy times xy times xy. And that would be the same if I just rearrange things a bit as x times x times x times y times y times y, which equals x to the third times y to the third. And there is similar logic for both of these, that if you wrote out x times x times x times, so that's my x to the third, times x times x times x times x, I would see that that comes out to x to the seventh. But by knowing these rules, I save myself a lot of work and a lot of writing. For this next one, x squared raised to the third power, it's telling me that I have x squared times x squared times x squared. And if I wrote that out, that's x times x times x times x times x, one more, equals x to the sixth. So it's important to memorize these rules, have them down to the point where it just becomes automatic, because then you won't have to write all this out or rationalize each one. You just remember your rule. Multiplying exponential expressions with the same base, you add the exponents. Raising an exponential expression to a power, you multiply the exponents. And finally, if you have the product raised to a power, you can break it out so that each part of that product is individually raised to the power. What we're going to be doing today is putting some monomials in simplified form. So to define what that is, a monomial is in simplified form if each base appears exactly once, if there are no powers of powers, and when all fractions are simplified. For example, if I have 3x times 4x, this is not in simplified form because I have a base appearing more than once. Simplified form would be 12x squared. And what I did is I used my rule for multiplying exponential expressions with the same base, and I added the exponent, which is actually 1 for both of these. So 3 times 4 is 12, and then x times x is equal to x squared. So now this is in simplified form, and we're going to do this with more complicated expressions as well. Beginning with our first example. So when I'm looking at this, I see that I have a product here, so I need to multiply, and that I do have some terms with the same base. So I'm going to use my rule, multiplying exponential expressions with the same base, which says that if I have a to the m power times a to the n power, I'm going to add the exponents. Again, making that a bit more concrete, if I have x squared times x to the third, I'm going to get x raised to the 2 plus 3, which is going to equal x to the fifth power. Okay, so looking at what I have here, I have 3 times 4, and that is 12. Then I have a squared, adding the exponent for the other expression with the same base is going to give me plus 6. For b, I have b to the fourth. Over here, I have b to the seventh. And then finally, I have c squared. So I work this out. 2 plus 6 is 8, so a to the eighth power. 4 plus 7 is 11, c squared. So I look at this and I verify that it is in simplified form. Each base appears only once. So I have no duplicates. I have no powers of powers. There are no powers raised to other powers, and fractions are simplified. So this is in simplest form, simplified form. Okay. In my second example, I see that I have a product raised to a power. And remember that the rule for a product raised to a power is that AB raised to n is equal to a to the n times b to the n. So I'm going to use that logic to remove these parentheses. So that's going to give me 3 to the 5th times a to the 3rd also raised to the 5th power. Okay? Then I have b to the 4th. I'm going to apply the 5th power to the b to the 4th. That's going to give me b to the 4th raised to the 5th power times c to the 6th raised to the 5th power. So I used one rule. I used this rule. And now I have to use a second rule. And the second rule that I'm going to apply is the one that describes when I have an exponential expression raised to a power. So this was my first step, applying this rule. My second step tells me that if I have an exponential expression, such as a to the m, and it's raised to the power n, I'm going to multiply the exponents. Okay, so doing that in this case, well, 3 to the 5th, if you worked that out, it comes out to 243. Then I'm going to multiply 3 times 5 to get a to the 15th. b, 4 times 5 will give me b to the 20th power. 6 times 5 is 30, so I have c to the 30th. This is in simplest form. All fractions are simplified. I have 243. My bases appear only once, and I no longer have a power raised to a power. So up here it wasn't in simplest form because I had a power raised to a power. So this is simplest form using 2 steps. The first, to remove the parentheses. So this is the product raised to a power rule. And second, I use my rule for an exponential expression raised to a power. Okay, here's a more complicated scenario where I have products raised to a power. I've got these 2 monomials being multiplied by the other. So I'm going to have to take this one step at a time. First, I want to remove the parentheses, and I'm going to use my rule for a product raised to a power. So a product raised to a power, ab times n equals a to the n times b to the n. So I'm going to apply this 4th power to each term inside the parentheses. That's going to give me 2 to the 4th, a to the 3rd raised to the 4th power, b to the 6th raised to the 4th, c to the 7th raised to the 4th. Then I'm going to do the same thing over here because each term in here is being raised to the 3rd power. Negative 3 cubed times a to the 6th cubed, b to the 7th to the 3rd power, and then finally c squared to the 3rd power. Once I've gotten this far, I have powers raised to powers, so I need to further simplify this using my rule about a power raised to a power that tells me I need to multiply the exponents. So if you figure out 2 times 2 times 2 times 2, that comes out to 16. A, 3 times 4 is 12. So all I'm doing is multiplying the exponents at this point. And that's b to the 6th to the 4th power. So 6 times 4 is 24, b to the 24th. 7 times 4 is 28, c to the 28. Negative 3 times 3 is 9, times negative 3 is negative 27. 6 times 3 is 18, so a to the 18th. 7 times 3 is 21, and then finally 2 times 3, that gives me c to the 6th. I'm still not quite done because I've got bases that are repeated. I have A, B, and C are all present twice. So I'm going to group like terms to make it easier to multiply them. First, I'm going to put my constants together. So it's 16 times 27, negative 27. Then the terms with A in them. The terms with B to the 24th times B to the 21, and then my two C terms. Okay, once I have this, I'm going to apply the rule for multiplying exponential expressions. So a to the m times a to the n. So these are exponential expressions with the same basis. I'm going to add the exponents. 16 times negative 27, if you calculate that out, turns out to be negative 432. Here, I'm going to add. So I'll have A, and I'm going to add 12 plus 18 times B, 24 plus 21, times C to the 28th plus 6, which will give me negative 432. 12 plus 18 is 30. A to the 30th. 24 plus 21 is 45, and 28 plus 6 is 34. Now I verify that this is in simplest form. My fractions are simplified, my bases are present only once, and there are no powers raised to a power. So looking back, I had to use all three of the rules that we learned today. The first one, in order to eliminate the parentheses, I used a rule that discusses a product raised to a power. So I applied the exponent outside of the parentheses to each of these terms to remove the parentheses. Then I used my rule about a power raised to a power, and I multiplied the exponents, it's just 3 times 4, to give me a to the 12 and on down. Finally, I grouped terms with the same basis so that I could multiply those out more easily, remembering that if I'm multiplying monomials with the same base, I add the exponents. Once I did that, I had my expression in simplified form. Okay. The fourth example, again, a long, fairly complex expression. I'm going to start out with getting rid of my parentheses by applying my rule about products raised to powers. So starting with this first expression right here, I have negative 2/3, and that's raised to the 4th power. A to the 4th, raised to the 4th. B squared to the 4th. C cubed to the 4th. Starting with the second expression, that's 3/4 to the 3rd power. A to the 4th to the 3rd. B to the 6th to the 3rd, and then C to the 8th to the 3rd. This third expression, I've got A squared to the 6th and B cubed to the 6th. Next, I'm going to use my rule about a power raised to a power. So A to the m to the n equals A to the m times n. So multiplying this out, negative 2/3 to the 4th, if you work that out, you'll get 16 over 81. And this becomes A to the 4 times 4 is 16. B to the 8th. C to the 12th. So this was this whole first expression here. Now I've got it simplified to this. 3/4 cubed comes out to 27 over 48, so I've taken care of that. Here I have A to the 4 times 3, or A to the 12th, times B to the 18th, times C to the 24th. My last expression gives me A to the 12th times B to the 18th. And I'm not quite done yet because I have some like bases here. So I'm going to group the terms with the same base, and I'm going to use my rule that tells me that if I am multiplying expressions with the same base, I add the exponents. So I'm going to group my constants, and then all of my terms that have a as a base, which would be a to the 16 times a to the 12 right here, and then I have another a to the 12th over there. Then my b terms, b to the 8th, b to the 18th, and another b to the 18th. For c, I have c to the 12th times c to the 24th, and no c term over here, so just 2. Remembering my rule that tells me that if I have the same base, I will multiply as follows. I will add the exponents. Calculating this out, 16 times 27 divided by 18 times 48 actually turns out to be 1/12. Now here I need to add 16, 12, and 12. So that's 24 plus 16 is going to give me a to the 40th. Here I have 8 plus 18 plus 18. Those add up to 44. And finally, 12 plus 24 is 36. Finally, I have simplified form. No bases are repeated. A, B, and C are present only once. I have no powers raised to powers, and my fraction is in simplified form. So I started out with a pretty complex expression up here, and I began by removing the parentheses, applying these terms, the exponent to each of these terms according to this rule. Once I did that, I took care of my powers raised to powers by multiplying the exponents. Finally, I grouped terms with the same bases so that I could easily add the exponents to get my final expression in simplified form. So today on Educator.com, we were introduced to monomials and learned 3 very important rules that will be applied when you're working with monomials in the future. See you soon.